Section 8.2 is on factoring out the greatest common factor and factoring by grouping. When I have a couple monomials, I'm looking to find the greatest common factor. I'm looking for the largest number that I can divide each of the values by. So for example, 24 and 30 are divisible by 2, 3, and 6. Since 6 is the largest of those values, 6 is the greatest common factor. Look at the values 12, 15, and 20. 12 and 15 can both be divided by 3, but 20 cannot. There is no number larger than 1 that can be divided into all 3 of those. The greatest common factor is 1. Look at the next two, 9a to the 5th and 15a squared. Check out the numbers first. The greatest common factor of 9 and 15 is 3. And when it comes to the variable, the greatest common factor is going to be the variable with the smallest power. So the greatest common factor is going to be 3a squared. The reason this works is that 3a squared will go evenly into a squared and will go into a to the 5th. A to the 5th has extra a's, but it certainly has at least 2 of them. Let's look at the next two. 8 and 24. 8 goes into both of those numeric values, and x to the 5th is the greatest common factor for the variable component. 6, 10, and 15 can only be divided by 1, so the greatest common factor here is just the smallest number of n, or n to the 4th. 4, 16, and 8 can all be divided by 4, and for the x's, they all have at least one x, and for the y's, at least y squared. The greatest common factor of a monomial is the largest number that divides evenly in, and the smallest exponent on any of the variable components. To factor out the greatest common factor of a polynomial, we would first want to find the greatest common factor, then divide it out of each of the parts of the polynomial. So if my terms are 20x, 12y, and 28z, the greatest common factor is going to be 4. Since 4 divides evenly into all of those numbers, they don't share a variable. So we're going to divide out 4, and that's going to leave us with, in each the first term, 20 divided by 4 is 5x, 12 divided by 4 would give us 3y, and 28 divided by 4 is going to give us 7z. This is factored out. It's factored out with that 4 being written in front of the parenthesis. Remember that factoring is the opposite of the distributive property, so if I distribute this back in, I should get the original problem. Right. The greatest common factor between negative 15 and negative 25 is negative 5. When your first number is negative, you're going to factor out the negative. They don't both need to be negative for me to take the negative out, just the first one. And for the n's, we're going to take out n squared. And if I divide by negative 5n squared, we're going to be left with positive 3n, and negative 25 divided by negative 5 is positive 5. Since I took out n squared, I took out all of the n's from the second term. Let's look at part C. 18, 30, and 6 can all be divided by 6, and they don't share any x's since the last term doesn't have any. So let's divide that out to see what's inside the parenthesis. 18 divided by 6 is 3, x cubed, minus 30 divided by 6 is 5, x squared, plus 6 divided by 6 is 1. If there were 3 terms in the original, the inside of the parenthesis will also have 3 terms. 16, 10, and 8 can all be divided by 2. A to the second is the smallest number of a's, and b to the first is the smallest number of b's. If I factor that out, 16 divided by 2 is 8. I've taken out 2 a's, so I've got 1 left, and I've removed the b, so there aren't any b's left. Minus 5, a squared's gone, b is taken out, but b squared is left, and minus 8 divided by 2 is 4, and a to the 4th divided by a squared is a squared, and if I take the b out of b squared, I'm left with 1b. Alright, in example 2, I'm going to factor out a binomial GCF. Okay, so my binomial GCF, what I'm saying here is that 3x, 7n plus 2, and 5y, 7n plus 2, both have 7n plus 2 in common. If you factor out 7n plus 2, what you're left with in the first part is 3x, and the second part plus 5y. Let's do that again. We have a binomial in common right here. A squared has 4b minus n, and negative 2 also has 4b minus n. So if I factor out 4b minus 9, I'm left with a squared minus 2. That's going to bring us up to factoring by grouping. When I factor by grouping, I'm trying to get a binomial in common. So what I want to do is factor the first two terms and factor the second two terms separately. So the first two terms, x squared and 5x have x in common. If I factor that out, I'm going to be left with x from the first term and 5 from the second term. Plus, second two terms, xy and 5y have y in common. If I factor that out, I'm left with x in the first term and 5 in the second term. By factoring the first two terms and the second two terms separately, I've got two sets that have a binomial in common, and I can factor that binomial, x plus 5, out. And if I factor that out, I'm left with x plus y. So I've got a product of two binomials here as my result. This is called factoring by grouping. So the grouping part is when I group into two separate groups, the first two terms and the last two terms of my groups here, and factor each group ignoring the other, each group separately. So the first group has b in common. If I factor the b out, I'm left with a squared plus 2. The second group starts with a negative, so I'm going to factor out a negative, and there's a 3 in common. And if I take out the negative 3, I'm left with a squared. And if I divide out a negative, negative and negative will make that positive 2. Now the group a squared minus 2, or a squared plus 2 is in common. And then I have b minus 3 left. Let's try it again in part C and D. The first group, 10x squared minus 12y, has a 2 in common. If I factor out the 2, I'm left with 5x squared minus 6y. If you look at the next two, there's no number that divides into 15 and 8, so I would be able to factor out a negative x, and I would be left with 15 plus 8y. This is not going to work because my two binomial groups are not the same here. Okay? Let's rearrange the terms and try again. Move this minus 12y to the end. Now we're going to try factoring each of these groups. If we look at the first group here, I can divide them both by 5 and x. So if I divide 5x out, I'm left with 2x minus 3. The next group has a 4 and a y in common. So if we factor out 4y, we're going to be left with 2x, and divide 4 into 12, you get minus 3. Now you can see that the two groups are the same, so you can factor out the 2x minus 3, and you're left with 5x plus 4y. So sometimes you have to rearrange a polynomial before you're able to factor by grouping. Let's try the next one. If I look at 4mn and 28m, those can both be divided by 4m. Factor out 4m, I'm left with n plus 7. Plus, now n plus 7 have nothing in common, so I can't factor anything besides 1. Take the 1 out and you still have 1 times n plus 7. That is going to work, however, because n plus 7 and n plus 7 are in common. So if I factor out n plus 7, I'm left with 4m plus 1 as my second factor. Let's go on to the next page. Completely factoring polynomials. The first step is always factoring out a GCF, if there is one, then checking to see if you can factor further. If you cannot factor at all from either steps 1 or 2, then the polynomial is prime. Part E right here, we want to factor. We can see that we have a 5 that goes into everything. So I'm going to start by dividing that out. It's going to give me 5 times, divide 5 out, t squared, plus 3t minus 10. Now I need to see if I can factor this again. To factor this again, I'm going to take my negative 10 and try to break that up into two things that are going to add to 3. Since the 10 is negative, I know one positive, one negative with a larger positive. So 5 minus 2 is 3, so this can be factored further. So we're going to factor into, leave your 5 outside, and t plus 5, t minus 2. So this is 5 times t plus 5 times t minus 2. Part F, 30x squared, 75x, and negative 3x cubed is not written in the correct order. The first thing I need to do is write it in descending order. So it'll be negative 3x cubed plus 30x squared minus 75x. Notice that the first term is negative, so I'm going to factor out a negative, and it's going to be a negative 3x, since these can all be divided by 3 and x. If I divide out negative 3x, I'm left with x squared. If I divide out negative 3x, this is going to be negative 10x. And dividing out a negative 3 again is going to make this a positive 25. Alright, let's try factoring that again. We're going to look for two numbers that multiply to 25 and add to a negative 10. So since they multiply to a positive 25 and add to a negative, they're both going to have to be negative. So it goes into 25. We can use negative 5 and negative 5 are going to add to a negative 10. So this is going to factor into negative 3x times x minus 5 times x minus 5. Or, since both factors are x minus 5, you could write that as negative 3x times x minus 5 squared. Let's look at part G. Part G only has two terms. Notice that you can divide them both by 4. Let's do that to begin. So we're going to have 4 times x squared minus 9. Now it's only two terms, so we want to see if it's a difference of squares. If it's a difference of squares, we can factor that some more, and it is. 9 is a perfect square. So it's going to be 4 times x plus 3 and x minus 3. In part H, two terms, they do have something in common. They're both going to be divided by x. Let's divide that x out. It's going to give us x to the 4th minus 1. And again, I have a difference of squares right here. X to the 4th is x squared squared, and 1 squared is 1. So I'm going to factor this into x squared plus 1 times x squared minus 1. Once more, I have a difference of squares right here. X squared is x squared, and 1 squared is 1. So we have x times x squared plus 1 times x plus 1, x minus 1. These are the binomial conjugates that factor from the difference of squares. And that's it for the section.